Hi everyone, my name is Quentin, and I'm a software engineer at CoreOS. I will talk to you about identifying vulnerabilities in containers with Clair. So that is how deployments used to look like. We had an ops team managing the operating system and a known set of dependencies, on top of which applications will be developed by developers. The responsibilities were well defined, so everything was smooth and easy. But was it though? Anybody who have experienced that know that this was simply a nightmare. 8 a.m., some developers will ask the ops to upgrade a Python. 8:30, the ops will get paged because their prod went down. 9, everything is back up. Python has been rolled back. Well, everybody cries. Nobody had their coffee yet. Like it wasn't enough, at 10 a.m., another team requests the bleeding edge version of Java, released just 12 hours ago. Something had to change. So containers coped with that situation. So ops installed container runtimes on their machines and asked the developers to package their applications into containers along with all their dependencies. Every developer could then get their very own dependencies with their very own versions, regardless of the other developers and regardless of the ops team. Well, ideally, containers should be quite small. But in practice, containers tend to be gigantic. This is because based images such as Ubuntu or CentOS or even Debian are used, and they ship hundreds of useless packages with them. Eventually, when more and more containers are created, no one is sure anymore of what's actually shipping and running in prod. I really like this small Docker file on the right over there. I cannot tell at all what's in the container. But there are some spooky things out there as well. Does anyone know what this little ghost is? You do know. All right. So this is Ghost. This is a vulnerability that came out last year and that affects glibc, more specifically the getHostByName function, and that allow a remote attacker to execute arbitrary code on your machine. I bet everyone knows this one, right? OK. So that one is Heartbleed. This is a 2-year-old vulnerability. That one affects some implementation of OpenSSL and may lead to private key leakage, for instance. But there are more. There are over 76,000 vulnerabilities listed on the National Vulnerability Database. And as I just showed you, like some of them became so famous that they got their own brand. They have a logo and they have a name. So to sum this up, we have a lot of containers running in prod. Nobody really knows what's running in them, and we have a lot of vulnerabilities are waiting to be exploited and leading to disasters. So about a year ago, we asked ourselves, how can we improve the situation? And this is how we came up with Clair, an open source project for the analysis of vulnerabilities in AppC and Docker containers. Before going any further and explaining how Clair works, I would like to show you what kind of insights Clair can give you. So to do this, I will use our integration with Quay, which is our container registry. So a couple of weeks ago, I found an Nginx image, which is a web server image. I wanted to deploy a simple website, you know. So I found this image publicly available on the internet, and I decided to push it on Quay. Before deploying this container, I decided to take a look at the security report. Can anyone read? No, I guess you cannot. All right. Can you read now? Is that OK? OK, cool. So I clicked on that web page, and I get horrified. This simple web server apparently has almost 600 vulnerabilities, and I was just mind blown. This includes over 100 high-level vulnerabilities. So I scrolled down a bit, and I found some crazy things like OpenSSL vulnerabilities right here. We have another one here. So we can actually expand this and read that this vulnerability may allow remote attackers to execute arbitrary code. If we look at the vectors, so it can be accessed remotely. It's super easy to exploit. It doesn't need authentication. So yeah. Let's take a moment to, All right. So this is introduced by OpenSSL in my container because I have version 101K1. We can link current version in the container, right? And I could fix it if I upgrade OpenSSL to that version, which is apparently not very far off. If I scroll up, I can actually see that over 400 of this vulnerability can be fixed by upgrading my packages. All right. So now we can also go to the second page here, which is a list of all the features that Clair detected on our image. And that include pcray, OpenSSL, Git. The columns that I want to show you here are not present because of the format. I may just unscroll. All right, there we go. So we can read that by upgrading, let's see. By upgrading OpenSSL, for instance, I could remove 7 high vulnerability and 19 other, like lower vulnerabilities. So that upgrading that package has a great impact on my container security. Let's go back to that page, actually. There is something even more interesting about that image, and this is why I picked that one up. If we scroll down, let's see. What do we have in that container? It's crazy. All right, I'm going to filter it. It's going to be easier. All right. A vulnerability caused by MySQL. Why? I thought this image was simply Nginx, a web server. So why do I have a vulnerability affecting a database? So this is linked to what I said before, that containers are often shipped with a lot of stuff we don't really matter. We don't really care of this, right? I just wanted a web server. And I mean, this one is vulnerable, so, All right. So then I fixed a bunch of stuff on my image, and now that I feel comfortable, I'm going to ship it in prod, right? Or maybe not. But then I don't want to come back on that page and read again that security report, because this is way too depressing. So what I'm going to do is setting a notification. So I'm going to ask Clair and Quay to tell me when everything blows up. I will say, OK, so alert me when a vulnerability is found. I don't care about medium vulnerability. I only care about high and above. So I'll select this. And then you'll send me, let's say we can set up Slack notifications, for instance, email. I'll just set up a local notification for the purpose of this demo. All right, create notification. Cool. So now I'm going to create a fake vulnerability on Clair, just for the purpose of this demo. I'm doing it using the API. And now if I refresh the page, hopefully I will get a new notification right here telling me that my image is not vulnerable to a new vulnerability, critical vulnerability. And this has been done in just a couple of seconds. All right, coming back to the presentation. Thanks. All right, I'm now going to discuss how did we actually do this. So first of all, we need to get some vulnerabilities. So to do this, we're going to periodically pull external databases. Clair is going to ask databases about vulnerability and then store this vulnerability in its internal database. Clair exploits first-party databases as much as possible because these databases know very well how their packages are vulnerable. And this is because they have knowledge about implementation details, about backports. So these databases are, for instance, like the Ubuntu databases, the Debian or Red Hat databases, which are very, very well maintained. Last week, I actually discovered a Java vulnerability. And interestingly, that Java vulnerability was not affecting Debian stable, and I wonder why. So I went on their website, and apparently that vulnerability was created by a patch to a previous vulnerability, which wasn't put into the Debian repositories yet. So that's interesting. Then once we have vulnerabilities, we can start analyzing images. In the case of an integration with a registry, this will be done by the registry itself. But it can be basically anyone. It's just about talking to a RESTful API. So we do analysis layer by layer. So you must know that Docker images are made of different layers. So what we do is we analyze them one by one, because some images share a lot of layers together, and we don't want to do the analysis twice or 10 times if we have 10 images sharing the same layers. This is because Clair has been designed to analyze millions of different images. So we had to make some decisions and optimizations. All right, so then the layers are passed to the worker, which will pass the layers to detectors. We have 3 different kinds of detectors. First of all, we have data detector over there. So data detector try to extract static content from the images, from the layers. It depends on the image format. So it might be AppC, it might be Docker, it might be OpenVZ, for instance. Then we have the main type of detector, which is the feature detector. And this represents basically anything that can be in the container. This can be packages, such as OpenSSL, Nginx, MySQL, can be keys, can be configuration parameters. For instance, if you don't want to ship production configuration into your images. And finally, we have namespace detectors, which draw a context between the detected features and the vulnerabilities. This is, for instance, saying that, that a package has been installed for Debian 7 and not Debian 8. So after a couple milliseconds, up to a couple seconds, depending on the size of the image, we have analyzed our image. And we're now able to know which vulnerability may affect them, what can be fixed, as we saw in the demo, and how can we fix them. Now, over 15 new vulnerabilities are published each day. And this is not even counting all the updates to them. So what do we do when these new vulnerabilities come out? Do we reanalyze every single image as we analyzed before? Of course, we won't do this. Instead, we exploit the immutable nature of images. What we knew about the static content of these images was true, is true, and will be true in the future. So Clair instead matched the new vulnerability data with all the knowledge it had about these containers before, and will match this together and be able to send notifications to the registries or clients saying, hey, your container that we analyzed 2 months ago is now vulnerable to that very new vulnerability. Finally, about this architecture diagram, what is pretty cool, and I think is very important for Clair, is that every component in red is more like black on that screen, I guess, or extendable. Basically, anyone can register their own behavior and logic. If your company have an internal vulnerability database or some policies that they want to enforce, this can be done by implementing some interfaces into Clair to let Clair know that something should be considered as a vulnerability for you. So for the next releases of Clair, we would like to extend detection capabilities. This is, for instance, adding Alpine Linux support, which is very important to us, but they don't currently have machine-readable vulnerability database, so this is not easy to do. We would like to implement other stuff like NPM or Python, OWASP. We'd like also to integrate a command line tool because Clair has been designed and produced for registry usage and developer usage, but not for everybody's usage. So it's not super easy to use an API for everybody. And basically, anything we'd like to see because it's open source. So any contribution are very much welcome. Thank you so much. Any questions?
Can you talk a little bit more about how vulnerabilities are defined? So let's say I have a custom Debian package that my organization builds and it versions it differently. How are they defined?
Right. So currently, Clair is not able to keep track of your custom builds. This is definitely something that we want to see. And that's something that we thought about. We may use some metadata in your image to do this. Currently, we only keep track of major Linux distributions. Yeah. Does that answer your question? Anyone else? Anyone else? All right.